Okay, so in chapter 4, we're going to talk about triangles and triangle congruence. Okay, so we know what a triangle is. It's a segment. It's a figure formed by 3 segments joining at 3 non-collinear points. So, for example, 3 segments, okay, all joining at different points. And we can classify a triangle by its sides and by its angle measures. So we have 3 different classifications for sides. We have equilateral, which means I have 3 congruent sides. I have isosceles, which means I have 2 congruent sides. Or I have scalene, which means I have no congruent sides. For angles, I have 4 classifications. An acute angle, which has just 3 acute angles. Acute triangle, which has 3 acute angles. Equiangular, which is probably a newer one you haven't heard, which means all 3 angles are congruent. Okay? Just like equilateral, equi just meaning equal. So equilateral, lateral meaning side, means all 3 sides are equal. Equiangular, angle, and equi meaning all same angles, or equal angles. A right triangle, okay, which is a triangle consisting of 1 right angle. And an obtuse triangle, which has 1 obtuse angle. So if I were to classify these triangles based on the information I'm given, for the first one, because I have 58, 65, and 57, which are all less than 90 degrees, making them all acute angles, this would be an acute triangle. Okay, for my second one, and also, we have no no side measures indicated, which means we can't assume any of them are the same, so this would be an acute scalene triangle. Okay, because there's nothing indicating that these angles or these side measures are the same, which means that we have to assume that they're all different. For the second one here, I do see I have a 130 degree angle, which means this is obtuse. And because I have 2 tick marks, I know those 2 sides are congruent, so it's an obtuse isosceles triangle. Okay, so vertex are those corners where each side is going to meet. So for instance, if I had a triangle like this, each of these corners would be a vertex. And plural for that is vertices, as we learned in chapter 1. Adjacent sides would be 2 sides that share a vertex. So for instance, if I were to look at this side and this side, because they share this vertex, we could say that they are adjacent sides. When we talk about right triangles, we have other terminology here. We talk about the legs and the hypotenuse. You guys remember from earlier grades, the hypotenuse is always the one that's across from the right angle. And then the other 2 sides of this triangle are called legs. Okay, if we look at this example 2, the diagram shows a triangular loom. Explain why triangle ABC is an isosceles right triangle. Alright, well, for starters, we know that it is a right triangle because we have a right angle. And then it's isosceles because I'm shown that 2 of the sides are the same. So why is it an isosceles triangle? Because it has 2 congruent sides and a right angle. For part B, identify the legs and the hypotenuse of triangle ABC. So again, hypotenuse is always across from the right angle, so side AB is the hypotenuse. And sides AC and BC are the legs. Okay, the base of this triangle, we're going to come back to. Don't worry about that for now. Okay, we'll talk about that in 4.6 when we talk about isosceles triangles a little bit more. Alright, interior angles, pretty self-explanatory, are the angles on the inside of the triangle. So in this diagram, angles 1, 2, and 3 will be the interior angles. Exterior is a little bit trickier. For an exterior angle, I take my regular triangle that I have and I extend the sides of the triangle, and then these angles that I get on the outside would be my exterior angles. Alright, triangle sum theorem is a big one that we're going to see over and over throughout the rest of the course of geometry, and it simply says the sum of the interior angles of a triangle is 180. Okay, so that means if I have a triangle here, and say this angle is 90, and this angle is 40, okay, 90 and 40, that gives me 130 degrees so far. Okay, what this theorem is saying is that this angle then has to be 50 degrees because I need them all to add up to 180. My exterior angle theorem says that, so the exterior angle theorem says that the exterior angles of any triangle is measured to equal the two non-adjacent angles. So again, if we look at a picture, remember the exterior angle is caused by extending one of the sides of your triangle. So for instance, if this angle were 50 degrees and this one were 60 degrees, then this angle here would have to be 110 degrees. So let's look at that again. All right, the sum of the measures of the two non-adjacents. Remember, adjacent will be next to each other. So this angle right here is adjacent to 110. So we're looking at the other two. If I add those together, I can get whatever this exterior angle is. So for an example, if we want to apply this, move this over a little bit. Alright, so if we want to apply the exterior angle theorem here, the two non-adjacent angles, okay, so x plus 65, okay, sorry about that. So we have exterior angle theorem. Alright, so if I wanted to find this, my two non-adjacent angles would be these two. Okay, so x plus 65, and I can set them equal to this one. So 2x plus 10. Okay, so when I solve this, I get x and 55. Okay. So I get x equals 55. Alright. So, if the sum of the interior angles of a triangle add up to 180 degrees, and a right triangle already has 90 degrees, what is true about the others? Okay, so this is a corollary, and if we just think about what it's saying, if I have a right triangle, okay, and that's 90 degrees, okay, so that's 90 degrees, alright, then if they all have to add up to 180, what does x plus y have to add up to? So let's think about it. X plus y plus 90 equals 180. So if I subtract the 90 degree angle I already have, x plus y has to equal 90. So all this corollary really means is that if I have a right triangle, instead of saying all three angles have to add up to 180, I can also just say the two other acute angles aside from the right have to add up to 90. Now if that's confusing, don't worry about it. You don't have to really use the corollary. We can always just use the triangle sum theorem, which just says all three add up to 180, and that's fine. Okay, the measure of one acute angle of a right triangle is 2 times the measure of the other acute angle. Find the measure of each acute angle. Okay, so we have a right triangle. Okay, and it says one of them is 2 times the other. So let's call this first one x, because we don't know what it is. If that one's x and the other one is twice that one, then the other one would be 2x. Okay. Well, 2 ways we can do this. Again, we just said that the two acute angles have to equal 90 degrees, Or we can say all three together have to equal 180. Either way, we wind up with 3x equals 90, therefore x equals 30. Okay, so either way we get the same answer. Alright, and that's it for the first section.